Welcome to Study Loop.
The magnetic field inside a solenoid is B is equal to mu naught N times I over L, where N is the number of turns in the coil, I is the current through the coil, and L is the length of the coil. And we also know that the definition of self-inductance tells us that L is equal to the number of turns in the coil, N, times the flux through each coil, phi, divided by the current through the coil, I. And the flux through each turn of the coil, phi b, is defined as mu naught times N times A times the current I over L, where A is the cross-sectional area of the coil. So if we combine these expressions, we can rewrite L as follows. So L, we know, is N times phi b over I. And if we substitute our expression for phi, we get that L, the inductance of the coil, is equal to mu naught times N squared times A, all divided by L. As you can see, the current I disappears, and hence the inductance does not explicitly depend on the current. So now that we have an expression for the inductance, we can calculate the inductance for these given values in part B. But first, let's calculate the cross-sectional area. So the cross-sectional area of the coil, we assume it's circular, is equal to pi r squared. And this is pi times the given radius of 0.075 times 10 to the minus 2 meters, and that's all squared. And hence we get the cross-sectional area to be 1.767 times 10 to the minus 6 square meters. So now that we have the cross-sectional area, we can calculate the inductance from the equation above. So the inductance of the spring is equal to mu naught N squared times A over L. And we have all these values. So mu naught is simply 4 pi times 10 to the minus 7, and we'll suppress the units. The number of turns in the spring is 50, so N is 50, and that's squared. And A we calculated to be 1.767 times 10 to the minus 6 meters squared, all divided by the length of the coil, which is 5 times 10 to the minus 2 meters. And hence we get an inductance for the spring to be 1.11 times 10 to the minus 7 henries, which is simply 0.111 micro